Okay, good morning everyone. Today we are going to revise on kinematics. So kinematics basically it is the study of motion. Now in kinematics we are going to describe motion in two categories. So the first category is what we call scalar. The other one is called vector. So if you can recall, basically scalar only have what we call a magnitude. So a magnitude is basically a number. For example, if I talk about your age would be 14. So that means 14 years old, right? So that is 14 is the magnitude. So because your age will only go up, it will never go down. So we say that for scalar quantity, it is something that doesn't have a direction. Or in your case, your direction is only like forward, backward, up, down, left versus right. So in another word, your direction only have two options, either positive or negative. So if we want to describe direction in your syllabus, we will use something as vectors. So vectors has two components, the direction and the magnitude. Now most of the time this direction is expressed as positive or negative in your syllabus, because like what I said just now, in your syllabus the direction only have two options, up versus down, left versus right, forward versus backwards. So that is vectors to you. Now after you understand that there is this thing that differentiate between scalar quantity and vector quantity, we can then describe motion. So in the most simple form, which is what you learn in lower secondary, we describe motion in a few terms, right? Of course there's time, but other than that, there is distance, there is also speed. So these two quantity, distance and speed, I think you guys are very familiar. So in upper secondary, what you are going to learn is that now you are aware that we can actually use plus and minus to differentiate direction. Distance, we can now express it as a vector quantity. We call it displacement. And then for speed, if we want to indicate the direction in positive or negative terms, it is called velocity. There's one new one that you need to learn, and that is your acceleration. Now some of you may be asking me, okay, so what is displacement? Displacement, basically it is still measured in meter, like your length or your distance. It's just that it will have positive and negative. For example, if I have a starting point here, or maybe I draw in the center, that is easier. So if I have a starting point right here, if I decided to go forward and then I end here, we say that my displacement is maybe positive 2 meter. And if I decided to go in the other direction, then we say that it is minus 2 meter. Now having said that, it also means that if I decided to start here and that I go in a round circular track and then I end over here, we would say that the displacement is 0. So essentially, if you want to express or define displacement, you can define it by this expression. That is, your displacement is basically your final position minus your starting position, or what we call initial position. Okay, so maybe I write it out clearly. So your displacement is equals to your final position minus your starting or initial position. So I try to use layman term for you so that you can understand it better, but in your textbook, starting position is known as initial position. Now velocity is quite similar to your speed. It is also measured in meter per second. So for example, if I have the term positive 10 meter per second, what it means is that it is moving in the positive direction, and basically every 1 second I will move in the positive direction by 10 meter. If I have negative 10 meter per second, that means I am moving in the negative direction 1 second minus 10 meter. So in another word, your velocity, basically the plus or the minus, will tell you the direction that the object is traveling. Okay, maybe I write properly. So this one over here, basically the plus and minus will indicate your travel direction. Okay, that is a T. Now the last one is what we call acceleration. So acceleration has a special unit. Okay, acceleration basically has the unit of meter per second square. Now what acceleration is that it is actually the final velocity, what we call v, minus the starting velocity u over t. So if you understand this mathematic, right, when I have acceleration equals to 5 meter per second square, what it means is that I would have time and my velocity. If my starting time is 0 and my velocity is 1, and if I have an acceleration of 5 meter per second square, what it means is that after 1 second, my velocity will be increased to 5. After 2 seconds, 6. Okay, because 1 plus 5 equals to 6. After 2 seconds, what will it be? It will be 6 with an acceleration of 5. It will be 11. So basically, acceleration tells you how quickly your velocity actually changes. It can be an increment or it can be a drop. So what do you mean by a drop? For example, let's say if I have another example, let's say I have an example of a equals to minus 3 meter per second square, and I decided to start my velocity with, let's say, 12. After 1 second, if I have an acceleration of minus 3, it will be 9. Then after 2 seconds, it will be 6. After 3 seconds, it will be 3. After 4 seconds, the object will come to a stop. Okay, so that is what it means by a negative acceleration. Okay, now what you notice is that when you have an acceleration that is negative, for your current syllabus, it is actually called deceleration. That means it is slowing down. And if you have a positive acceleration, this means that it is speeding up, acceleration. So when we say that an object is accelerating, it means that it is speeding up. If we say that an object is decelerating, it means that it is slowing down. So when you have this parameter, just be very careful. When we have positive or negative velocity, the plus and minus tell you the travel direction. So if you have a negative acceleration, does it mean that you are going backwards in the negative direction? No. Acceleration tells you whether an object is slowing down or whether an object is speeding up. So be very careful, just remember, okay? Velocity tells you the travel direction. Acceleration tells you whether an object is speeding up or slowing down. Now I just want to make a disclaimer that in the NA syllabus, because it is more simple, when you have a negative acceleration, it means slowing down. But when you go for your poly courses and all that, you will learn that actually there can be more complex or different cases. So basically what I have recapped with you are the basic physics vocab, displacement, velocity and acceleration, and you need to know what it means. And you can see that down here, there's only one formula, which is over here. Now, for kinematic, it is not always just about calculation. Sometimes they may represent the motion in graphs. So actually, there are two graphs that you need to familiarize with yourself. For example, they can give you something like a velocity or speed time graph. Now, this velocity and speed time graph is actually nothing that is scary. It is quite straightforward. So let me recap with you what we have here. Okay, so for a velocity or speed time graph, what you need to remember are two things. Number one is that in the gradient of this VT graph, we call it speed time graph, basically will show you the acceleration of the object. And if you look at the area under the VT graph, it will show you the distance or the displacement that an object has traveled. Now, what does this mean? For example, if I have this particular graph, okay, and let me add some dummy values to it. Maybe 8. Okay, now if I were to use this graph and test you, what does it mean? Well, it is quite simple. So I want you to follow my logic. First, I will check what is my starting speed or velocity. I can see that my starting speed is 0 at time 0. This one, at time 0, my velocity is 5. So it means that I start off moving. Then I go and check, okay, at a later time, t equals to 1, my velocity has actually changed to 10. So what it means is that it must have changed from v equals to 5 to v equals to 10, right? So actually from here, we can already tell that down here, let's call this part A. So we can tell that your A, the object, is actually speeding up from 5 meter per second to 10 meter per second. In another word, the object is accelerating, right? Yeah, it is speeding up. So this is what we call a noun. So in physics, if you want to describe motion, you describe it in terms of a noun and an adjective. So for a noun, it can be velocity or it can be acceleration. And the easiest way is to look at the acceleration. So if I want to describe the motion at A now, I can say that it is accelerating, right? But that is a noun. I need to add in an adjective. So how do I choose what adjective I have? So there are 3 adjectives that you can choose. You can choose the adjective constantly, or you can choose the adjective increasing, or you can choose the other adjective that is decreasing. So what does these 3 means? I will give you an example. So for example, if I have constant acceleration versus I have increasing acceleration versus I have decreasing acceleration, I'm going to show you what it means. So for example, if I have constant acceleration, let's look at it in terms of TV, and TV. Now, if I have constant acceleration, let's say I start off my my velocity as 5. After 1 second, if I have a constant acceleration of 2, what it means is that after 1 second, my velocity will be 7. After 2 seconds, my velocity will be 9. And then after that, 3 will be 11. How do I know that? Because 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. Can you see that for this particular case, my increment is constant, right? That is a constant increment. So that is what we mean by constant acceleration. How about increasing acceleration. So increasing acceleration will be something like this. 1, 2, 3. Let's say I start off with 5, it will be 7, then after that it will be 10, and it will be 14. Now, what does this mean? 5 plus 2 becomes 7, 7 plus 3 becomes 10, 10 plus 4 become 14. So what you see here is that, can you see that the increment is becoming bigger and bigger and bigger? So that is what it means by increasing acceleration. Okay, what does it mean by decreasing acceleration? Well, decreasing acceleration would be something like this. 2, 3. I start with 5, it becomes 7, then it becomes 8, then it becomes 8.5. What is the increment like? Plus 2, plus 1, plus 0.5. Can you see that this increment is becoming smaller and smaller? So I just want to make it clear to you that decreasing acceleration doesn't mean that the object is slowing down. It is not deceleration. As you can see here, decreasing acceleration, my velocity is still on the rise. It changes from 5 all the way to 8.5. It's just that the increment over here, the blue one, okay, it is getting smaller. The increment becomes smaller. So this is what it means by constant acceleration, whereby the increment is the same. Increasing acceleration, whereby my increment is getting bigger. And then lastly, I would have decreasing acceleration, whereby my increment is actually getting lower. You would realize that these three, there is a similarity. The similarity over here is that your velocity or your speed is always becoming bigger. It is just that the increment over here may change. Constant acceleration, increment is the same. Every increment is the same. Increasing acceleration, every increment is getting bigger. Decreasing acceleration, the increment is getting smaller. So that is what it means by these three adjectives. Okay, so now once we understand this part here we can, this part here we can cut, right? Okay, cannot cut. So maybe we erase them first. You can pause the video and then so now that we understand what it means by these three adjectives, then we can take a check. Okay, now what happened is that after you understand constant, increasing, decreasing, actually to interpret the graph, there's a easier way. And the easier way is to, of course, look at the gradient of your graph. So if I look at the gradient of this part, because I want to describe that, right? A straight line means that it is constant gradient, and gradient is acceleration, right? So we just replace the word gradient with acceleration. So we can see here that your acceleration is constant. And that's it. If we want to find out what is this acceleration, we can then make use of the gradient. So for example, your gradient over here is given by your coordinate, which is down here 110, down here 0.5. So you can actually calculate the gradient very quickly, and you can see that the gradient here is 5 meter per second square. So this thing over here will be your acceleration. Now similarly, we can do the same thing for the rest of the graph. Let's say I want to look at here. I need to describe the motion. What is the how would you describe the motion? First, you look at the gradient. What is the gradient? The gradient is, a flat line has a gradient of 0, right? So the gradient is 0. So how do you describe motion? Just change the word gradient to acceleration. So acceleration is 0. Oh, I forgot. 0 is also an adjective. Okay, so gradient is 0. What does it mean? It means the speed or the velocity doesn't change. Okay, let's say this is B. Now how about if I want to describe C? Well, C is quite simple, right? Let's look at the gradient. What is the gradient? Oh, the gradient is a straight line, right? So the gradient is constant. Now you also notice here that this gradient is negative, right? So how would you describe its acceleration? Replace the word gradient with acceleration and then just say acceleration is constant and it is negative. So my question to you is, now that I have go through all this, I'm trying to teach you how to describe motion in terms of acceleration. Now, having said that, if you look at this part over here, does it mean that the object is having a U-turn? That means, is it moving back to where it is? So I just want to highlight to you, remember what I said here. Positive or negative velocity tells you the travel direction. If you look at your graph over here, A, B, and C, can you see that A velocity is all positive, B velocity is all positive, C velocity is all positive. So actually what happens to this object is that basically from here it has moved at constant acceleration, then after that it moved with constant speed, which is your B, and then after that it is slowing down to your C. So throughout the journey between A, B, and C, it is moving in one singular direction. So a lot of you, when you look at a slope that is negative, you may think that the object is returning to its original position. That is wrong. Okay, throughout A, B, and C, the velocity is positive, and it means that throughout A, B, and C, it is still moving in the positive direction. Yeah, so please do not confuse that, oh, if the slope is going down, it means that it is returning to its original place. No. Okay, a negative gradient here, a negative gradient just means that the acceleration is negative, and negative acceleration, as you can see here, it means that it is slowing down. That's all it means. Okay, so down here, if let's say I want you to tell me what is the distance traveled in A, how would you find? Well, if you want to find the distance traveled, then you just need to find the area under the graph, which is given by this area. Okay, do not just take the speed multiplied by the time. You need to find, for example, here, I want to find distance in the first 1 second. You need to find this area. So how do I find this area? Well, can you see that after I shade the area underneath, okay, it becomes a trapezium. And you can see that down here, it has a height of 5, width of 1, height of 10. So actually you can find the area just by simple geometry. Okay, so to find distance, you just need to refer to the area under the graph. So let me just recap what we have learned in this 20-30 minute revision. Number 1, kinematics is the study of motion. We describe motion in 2 categories, scalar or vector. Scalar means it only has a magnitude, a number. Vector means it has a certain direction indicated by a plus or a minus. It means forward versus back, left versus right, up versus down. And of course, a vector will have a magnitude. Then we have introduced to you 3 new words: displacement, velocity, acceleration. In short, velocity, whether it is a plus or minus, it shows you the travel direction. Acceleration, whether it is a plus or a minus, show you whether an object is speeding up and slowing down. After that, I show you what is a VT graph, a speed time graph, and then I try to teach you how to describe motion. For example, the question could ask you, can you describe the motion in A? And then you are supposed to look at the gradient. Okay, if the gradient is, for example, here in A, if the gradient is constant, you say that the acceleration is constant. If you see that the gradient is flat, like in B, you say that the gradient is 0. It means acceleration is 0. If you see that down here the gradient is in the negative direction, it is still a straight line. You say gradient is constant, negative, so it means that acceleration is constant and is negative, and it means slowing down. So that's how you describe motion from a VT graph. And then after that, I highlight to you that if you look at this entire graph, the V is positive. So remember, velocity plus and minus show you the travel direction. Even though the slope is downwards, it doesn't mean that the object is returning to its original position. A slope that is downward is trying to tell you that acceleration is negative. That means the object is acceleration is negative. This means that the object is basically slowing down. That's all. It doesn't tell you whether it is going backwards or not. Okay, so just remember that. Then after that, I share with you the last two pieces of information. How do you calculate acceleration from a VT graph? Okay, you look at the gradient. So that's how you calculate. How do you find the distance that the object travel from a VT graph? You look at the area, which is this area underneath. Okay, so basically that's all for your kinematic. It is a very short chapter. You can do this. You just need more practice. Okay, so now you can move on to your revision worksheet.